Listen, we are going to see properties of modulus of complex numbers. First and the foremost very important property is this, that is modulus of z square is equal to z into z bar. Otherwise z into z bar is equal to modulus of z square. Right, let's try to prove this. It's very simple. Let us consider a complex number z is equal to a plus ib, then its conjugate is z bar is equal to a minus ib, and its modulus value is root of a square plus b square. It's very simple. Let us take the left hand side, that is z into z bar, that is a plus ib into a minus ib. As you know very well, multiplying a complex number with its conjugate is very simple, that is real part square plus imaginary part square. This sum, real part is a and imaginary part is b. If you square it, your answer will be a square plus b square. Now a small technique we are going to do it. We are going to bring root to this problem, because to bring modulus of z, that structure should be root of a square plus b square. So try to put root. At the same time we must balance this, so we can put square on that. Right, so let us put square root and let us put square on it. So now this is root of a square plus b square, the whole square, square and root will get cancelled. You will get the same answer. Right, now you know very well root of a square plus b square is nothing but modulus of z. So this is modulus of z square. This is the property. This is very important property. Let us see while doing the problems, as well as while doing or while we are proving some complex numbers properties, this property will be very much helpful. Right, let's go to the next property, that is product rule on modulus. Right, what is that? That is, we have to prove modulus of z1 into z2 is equal to modulus of z1 into z2. What do you mean by this property? The property states if you have to find modulus to product of two complex numbers, there is no need for you to multiply the two complex number, and there is no need for you to simplify, and there is no need for you to take modulus after that. Simply take modulus to the first complex number, then simply take modulus to the next complex number and multiply it. So it is very simple and easy procedure. Right, let us try to prove it. Right, how to prove this? If you try to prove this using by keeping z1 is equal to 1 plus ib1 and z2 is equal to a2 plus ib2, it will give you a long work. It is a hard work. Let us do the same thing with another technique. Using the formula, what we have studied is modulus of z square is equal to z into z bar. That property we are going to use. So we are going to use this property. Right, if you use this property, what is the use? Because now modulus of z means you have only simply a number, there is no I. But we are going to do something with complex number. So let us do one thing. If you use this property, here there is no I, but if it is squared, it gives you two complex numbers, both are having I. So if it is possible for us to do like this, then this property can be proved very easily. Right, how to prove this? The same technique let us use, that is, instead of finding modulus of z1 into z2 straight ahead, let us try to find modulus of z1 into z2 the whole square. What will happen now? Using this property, this can be written as complex number into its conjugate. So this complex number, that is z1 into z2, this complex number into its conjugate. Now we can apply this formula. Modulus of z1 into z2 is nothing but z1 into z2 the whole bar is nothing but z1 bar into z2 bar. So we can apply this formula. Right, if you simplify this, z1 into z1 bar can be written as modulus of z square using this property. Right, and if you try to simplify z2 into z2 bar, that will be modulus of z2 square. So now we have proved modulus of z1 into z2 the whole square is nothing but modulus of Z1 square into modulus of Z2 square. By taking square root on both sides, we'll get the answer. Modulus of Z1 into Z2 is equal to modulus of Z1 into modulus of Z2. Right. Now let us try to do the division. That is, modulus of Z1 by Z2 is equal to modulus of Z1 by Z2. This property is also very much helpful while doing the problems, because if a problem is given like this, there is no need for you to simplify this complex number by taking conjugate, and then there is no need for you to take modulus. Simply take modulus to the numerator complex number and simply take modulus to the denominator complex number and divide it, you'll get the answer. That is this property. Right, let us try to prove this. How to prove it? Let us do a small technique. You know very well, Z1 can be written as Z1 by Z2 into Z2, because Z2 and Z2 will get cancelled. You will get Z1 equal to Z1. So we can write Z1 in this format. Now let us try to take modulus on both sides. Right, taking modulus on both sides, you will get modulus of Z1 equal to modulus of Z1 by Z2 into Z2. Right, now you know a formula, that is modulus of Z1 into Z2 is equal to modulus of Z1 into modulus of Z2. This is a complex number. Z1 by Z2 is a single complex number. Z2 is another one complex number. So if we take modulus, our answer will be like this. That is modulus of Z1 by Z2 into modulus of Z2. If you bring this modulus of Z to this side, your answer will be modulus of Z1 by Z2 equal to modulus of Z1 by Z2. So it's very simple. Right, I hope you have understood this property also. Let us try to do one more property that is also very important for problems. Right, that is how to take modulus to a complex number which has powers like this. That is modulus of Z power n. Right, this is that. How to take modulus to a complex number which has power. The property says no need of worrying about this power. Just take modulus to this complex number alone, then raise it to that power. That is very simple. Then we can put that power like this. So it's very simple. Let us try to prove it. Modulus of Z power n is equal to modulus of this Z power n is split at Z into Z into Z n times. You know the property, modulus of Z1 into Z2 can be written as modulus of Z1 into modulus of Z2. So we can split this property. Split this modulus like this. Modulus of Z into modulus of Z into modulus of Z, like this we can split it. It goes n times. That is, if you multiply modulus of Z into modulus of Z, that is modulus of Z square. If you multiply these three, you will get modulus of Z cube. The same way, if you multiply up to n times, your answer will be modulus of Z the whole power n. So we have proved modulus of Z power n is equal to modulus of Z the whole power n. Right. What is the use of this property? Is very important. For example, if I ask you to find 1 plus I the whole power 10 and its modulus, there is no need for you to find the value of 1 plus I the whole power 10. Simply take modulus to 1 plus I, then put whole power 10. That's all. So this property is also very, very important and very much helpful while doing problems with modulus. Now let's try to practice some problems and let's try to learn some problem. Right. Moreover, I ask you to prove this by yourself. Modulus of Z is equal to modulus of Z bar. The meaning is, if you for a complex number, if you take modulus, the same result you will get if you take modulus to its conjugate. So try to prove this also. This is also very much helpful. Right. Now let us try to find modulus of 2 plus 3i into 7 plus 4i. How to do this problem? If we do it very simply, we have to multiply this, then with this, then with this, Then with this, then you have to simplify and you will have a complex number. For that you have to take modulus. But the property says in another way, that is modulus of Z1 into Z2 is nothing but modulus of Z1 into modulus of Z2. So simply apply this property. So this is modulus of 2 plus 3a into modulus of 7 plus 4a. Just take modulus to this complex number and just take modulus to this complex number. You will have answer like this, that is 2 square plus 3 square, 7 square plus 4 square. If we simplify it, we'll get the answer like this, root of 13 into root of 65. If you simplify root 65, we can write this as root of 13 into root of 5. So final answer will be root 13 into root 13 is 13. Your answer is 13 root 5. Very simple. Right. Now, using all these properties, I request you to do some problems below. Right. First property, try to find this. How to find it? As I told you, don't take conjugate. Don't try to simplify, no need. Because the property says modulus of Z1 by Z2 can be written as modulus of Z1 by modulus of Z2. So take modulus to the numerator, take modulus to the denominator, then divide it, you'll get the answer. Similarly, try to find this problem, try to find modulus to this. This is also very simple. Just take modulus to this, multiply this modulus value. Then try to find modulus to this denominator, then you have to divide the numerator value. Very simple. Right. In case if the problem is like this, what to do? Don't worry about the power. As I told you already, just take modulus to this. For example, your answer will be 4 plus 9, that is root of 13. So root of 13 whole power 5 is the answer to this particular complex number. So apply this property, that is this property, modulus of Z power n can be written as modulus of Z the whole power n. So if you try to simplify this, you can write this as modulus of 2 minus 3i whole power 5 into modulus of 3 minus I divided by modulus of 4 plus 3i. Just take modulus and simplify it. So this is very easiest method to find modulus to the given complex number. Practice this. Moreover, by seeing your textbooks, example sums and as well as exercise sums, if you practice it, it will be very much helpful. Thank you.